So this lesson focuses on compound inequalities. And compound inequalities are sets of inequalities where there's more than one restriction on the values that your variable can be. In previous lessons, we just had, say, a number line, and we'd say that there was a certain number, maybe it's -3, and that our variable could either be or not be that number, but in either case, we would either be that number and then greater, or that number and then less, and we just shade in one direction or the other. In this lesson, compound inequalities talk about where there are sort of two things that describe what the variable can be. Maybe you'll have a number line like so, and we'll say that the points that matter are -1 and 4, and either your variable can be all the numbers in between those two and then nothing outside, or your variable might be starting at 4 and going up, or starting at 1 and going down, or -1 and going down, or both. So a compound inequality just sort of adds more limitations on the numbers that your variable can become. And the information we're going to use to practice here is a question sent in by a young lady named Ari. And she says that she has two graphs she needs to describe and would like our help figuring out what they should look like. The first one she has is right here. You'll notice that we have a solid circle at -2, and then we're shaded up to +1 on the other side of 0. So what she needs to do is describe this, what we call an interval, this section of the number line. And we can use regular inequality notation. If we do that, inequality notation, it would look something like this. We would say that when we're writing down what x can be, right? So what we can say that x has to be bigger than -2, or it can be equal to it. So x is greater than or equal to -2, but then x can't be as big as 1. So x then is less than 1. So this inequality notation here tells us that x is in between the two numbers +1 and -2. It's greater than or equal to -2 and less than -1. Now we could also write the same information in interval notation. Remember, with interval notation we say what's the smallest number we can be and what's the biggest number we can be. And since we can be -2, we use a square bracket on that side. So the smallest number we can be is -2, and we can be that number. And we go up to 1, but we can't actually be 1. So we use a square bracket on the left saying that's included, and a round bracket on the right saying that one's not. So there's our first example. And then her second question was this graph right here. I needed to describe this graph. So for this one, we're split in both directions. Instead of being centered sort of in the middle of the graph, we're going off in both directions. So we start here at -1. Now with our inequality notation, we would say that x can be smaller than -1, but it can't be -1. So this would be x is less than -1. And then x can be greater than 8. It can be anything bigger than 8. Or x is greater than 8. So this one's really two different inequalities, right? It's either less than -1 or greater than 8. So either way works fine. With interval notation, we have, again, two intervals. We'd either have the interval where our smallest number that we can't actually hit because you'd never actually hit infinity. Our smallest number is infinity, and that one goes up to -1, which we cannot be. And we're also including the interval where we start at 8 and we go up to +infinity. And sometimes you'll see just infinity, sometimes you'll see this little plus sign saying +infinity and a negative sign saying -infinity. But that's all they're saying, is we're going down as far as we can or up as far as we can. So there you go, Ari. Hopefully that helps you out.